Hey everyone, we're going to take a look at appropriate domains of graphs of real-world situations and just kind of better understand their constraints and boundaries when it comes to mathematical terminology. So let's get started. So for each of the following real-world scenarios, state the domain and range, and we're going to also add in the y-intercept. But that's kind of the idea of what's going on. You're not necessarily calculating too much here, but you are going to have to be very familiar with the terminology and the types of numbers that are used. So you have a savings account with $360 in it. You add 40 at the end of each week from summer job. The job lasts 10 weeks. How much money you have in the bank is a function of weeks. So function of weeks, and here's your little function. So just remember that the domain is input. Okay, so you need to understand what you're putting into the function. For instance, what is going in here? So back in the problem, it says that you add $40 at the end of each week. So it seems like you in the context of the problem, you are putting $40 in, but in the function itself, this x represents the number of weeks. And for the sake of this example, we're going to understand this to be positive integers. In other words, whole numbers. Okay, so what that means is you're putting in 1 week, 2 week, 3 week, and 4 weeks. And if we wanted to do that in the right notation, we would do 0 less than or equal to x less than or equal to 10. Because we know we're going to put in as much as 0 weeks, and the most we're going to put in is 10 weeks. So this moves us into our idea of the y-intercept. So when we talk about the domain, know these two things. What in the context is the input, and what types of numbers can go in. When we talk about the y-intercept, this is really the initial amount. Or in other words, when x or whatever your input is equals 0. So for instance, if we did a of 0 and did 40 times 0 plus 360, you would get just 360. It's typically always going to be that guy, unless the function set up differently. So your initial amount is $360. Now your range is a little different. With the range, you've got to know your starting amount, because that's your lowest y value. So we know it's going to be 360 less than or equal to y. But then what's the highest amount we could go? What's the most we could save? Because we know our input's the number of weeks. So if I didn't work any at all, I'd still have 360. But what happens if I worked every 10 weeks? So take your max input and say, all right, well, what's the amount after 10 weeks? Plug that in. 40 times 10 plus 360. You'll get 400 plus 360, which equals 760. And that's your range. So $360 is the least you can have, and 760 is the most. So let's look at number 2. A car traveling to Florida, all right, is moving at a constant rate of 73 miles per hour. The trip takes 6 hours. The distance traveled is a function of time. So time is our input. All right. Remember, domain is your input. So it takes 6 hours. So this is the number of hours. Okay. And in this case, here we're going to say the positive reals. real numbers, because you could travel, say, an hour and a half and 10 seconds and go into milliseconds and things like that. So positive reals, you might see this phrase as non-negative, which I don't like, but just be aware of that. So positive real numbers, non-negative real numbers. And it's the number of hours. Now, the most you can have, you could start on this trip at 0, less than or equal to x, and then the max amount of time this trip's going to take is 6 hours. So you're traveling anywhere from 0 hours to 6 hours. So remember, just going back to our idea of the y-intercept, the y-intercept is the initial amount. And the funny thing here is, if you haven't traveled anywhere, if you've spent no time traveling, guess how far you've gone? 0 miles. So, that's your initial amount, 0 miles. You've gone nowhere. So the range, what's the range? Well, we just said 0, but what's the most we could travel? Well, we know we go 73 miles per hour, and we know the longest we can take is 6 hours, so plug in 6, substitute in 6, and you will come out with, let's see, 438. So there's your range. So domain 0 to 6 hours, range 0 to 438 miles. All right, moving on. So for a science project, Jeremy records the growth of a variety of plants for a period of 12 weeks. One particular plant started at 10 centimeters tall and grew 2 centimeters per week. 2 centimeters per week. Growth is a function of weeks. Input, okay, is our domain. And again, it's the weeks. It's the number of weeks that have gone by. And this one, you could argue either way. You could say, well, let's actually go ahead and make a stand here and just say this can actually be the positive reals. Oops, sorry. Because in this one, you can check the height of the plant at any time. So a week and a quarter could go by, a week and a day and a minute could go by. And that's a little different than this first one, because at the end of each week, you put $40 in. Like, you're not putting it in halfway during the week. It's at the end of the week or it's not. In this one, yes, this one, it's saying it grows 2 centimeters per week, but it's still growing during that week. So we're going to say positive reals here. So what's the most it could grow? Well, or you can check in on it. Well, it always starts out here at 0. Not always on any function, but in this one it does. And then we're going to check in for a period of 12 weeks, and then this project is over. So what's our starting amount y-intercept? That's when x is 0. So if you put 0 in, 2 times 0 plus 10, you get 10. So the starting amount is 10. Obviously, it's right there. The starting amount was 10 centimeters. Okay. Now, we know the range, the lowest will be 10 centimeters. But what's the most it could grow? Well, the domain was 0. When we plugged in 0, we got 10 back. The most weeks it's going to grow by is 12, so throw 12 in, and that's your max that you're going to have. Because we could say, well, an infinite number of weeks are going to go by, so it's going to grow forever, but that's not possible when you kind of have these real world situations. So the most it's going to grow by is 34 centimeters if that's what it keeps growing by. So that's kind of thing. So remember, input, how many weeks go by? As the weeks go by, what's your output? How much bigger is it getting? So before this gets too long, I'm going to stop it there. If you have questions, let me know. Check the key. But other than that, just remember that domain is your input, range is your output. Know what each one is in words. Oh, the range is the height of the plant, because it depends on how many weeks have gone by. So just remember, domain's input, range is output, y-intercept is the starting amount when x is 0, and yeah, you'll be good to go.